Hi, welcome to the Properties of Matter Unit 2.2 notes video. So during this video, in addition to learning, you will also have to pause the video and grab certain handouts and complete those handouts before resuming the video. So let's get started. As we know in Unit 2, the goal of the unit is for you guys to identify an unknown substance that I give you, that I assign to you, based on its properties. And you're going to test those properties to sort of help you figure out what that substance can be. So to help us achieve that goal, in the 2.1, what we learned about is matter, and that matter is something that has mass and volume, and that matter is made of atoms. We also learned about the properties of matter and how to test those properties. And there were 8 different types of properties we looked at, and we talked about the different types of tests for those. In this video, we're going to learn specifically about the properties of elements. So all matter have properties, and then remember we can group or sort of classify things based on those properties. And the first classification that we're going to look at are the 3 different types of elements and their properties. So in order to achieve that goal, we have to know what an element is, and the 3 different types of elements, and the properties of those 3 different types. In addition to that, we're going to learn how to utilize the periodic table as a tool to sort of help us, given an element, predict its properties. All right, so let's start off with what an element is. We said that matter is made of atoms, right? Well, matter can be made of the same type of atoms or different types of atoms. And if you're dealing with a case where matter is made up of one type of atom, it's an element. Let's take a look at some examples here. Here we have models or particle diagrams of 3 different types of molecules. And so these are called particle diagrams because they're sort of like drawings, and they use somewhat circular shapes to show the shape, to show atoms that are connected together in these molecules. Underneath, we have the chemical formula and the name. So the chemical formula you've seen before, like a common chemical formula would be H2O. So in the chemical formula, it has the symbol for the element. So the symbol for a hydrogen atom is H, and it has a subscript which tells you, that little number there, which tells you how many hydrogen atoms or H atoms are in that molecule. And in this case, it would be 2. So we can see from both the particle diagram, which is our models, and the chemical formula underneath that each of these examples have one type of atom. It doesn't have one atom, just one type. So for example, for hydrogen, there are 2 hydrogen atoms, but those are the same type of atoms. There are no different atoms, just one type, just hydrogens. And in oxygen, there are 2 types, there are 2 atoms. Both are oxygen, but they're the same type. And the same thing with nitrogen. They're all the same. They're just nitrogen atoms here. And again, we can tell that from the formula as well, because as we can see that there's only one element symbol in each of these. Just hydrogens here, just oxygens here, just nitrogens. No matter what the number is. The number can be anything from 1 to 1,000. As long as it's the same type of atom, it's an element. On the other hand, compounds are made up of 2 or more different types of atoms. And here at the bottom, we have example of compounds. So nitrogen oxide, starting with that one, it has 2 different types. It has nitrogen atom and an oxygen atom. We can see that both in the model or the particle diagram and its chemical formula NO. H2O, that has 3 atoms in total, 2 hydrogens and 1 oxygen. But what makes it a compound is not that it has 3 atoms, it just that it has 2 different types. It has hydrogen and oxygen atoms. Those are 2 different types of atoms. And the same thing with NO2, nitrogen dioxide. It has different types. So just to recap, if there's only one type of atom, it's an element. And we can tell if it's an element from either the model or the chemical formula. Now what you're going to do is you're going to test your understanding with the CFU. So which substance is an element, which one is a compound? So take a moment to look at this. There's an optional sentence frame at the bottom. For this sentence frame, you would write the chemical formula first. So for example, for carbon dioxide, the chemical formula will be CO2. And then you would discuss whether you think it's an element or a compound, and tell me because it's made up of, and here you're going to give the number of types of atoms. So For example, in carbon dioxide, how many types of atoms do you see? Is it one type or two or three different types? So you would write that there. And then finally, you would write the element symbols. And what I mean by element symbols in carbon dioxide, there are C and O atoms, so carbon and oxygen atoms. And then for chlorine, it would just be Cl. So that's what you would write. All right, so you're going to pause the video now. When you press play again, the answer will be revealed. Okay, great. So here are the answers. CO2 is a compound because it's made of two different types of atom, carbon and oxygen. Again, we can tell that from the particle diagram and the chemical formula. And then chlorine is an element because it's made up of one type of atom, chlorine. All right, so now that we learned what a element and an element is, it's just something that has one type of atom. We're going to move on to the different types of elements. If you have a question about this would be a good time to pause and check in with either your partner or check in with me. Okay, so different types of elements. There are three, and you've heard of these types before. You should have at least through the homework. Metals, nonmetals, and metalloids, which are also known as semi-metals. So here we have images of samples of different types of elements, and some of these are metals, some of these are nonmetals, and some of these are metalloids. And each type of element has its own properties. So metals have their own type of properties, nonmetals have their own type of properties, and metalloids have their own types of properties. So for example, metals are conductors, meaning that they can conduct electricity or heat, whereas nonmetals are insulators. So that means that if you're given an element and I tell you it's a metal, then you can make the assumption, oh, this is going to be a conductor. But if I give you another type of element and it's a nonmetal, you can assume like, hey, this is going to be an insulator. So, well, can we tell just by looking at it, like what's what? All right, so let's see. We're going to do an element exploration. You have three different groups of elements. Group 1, 2, and 3. And what you're going to do is for each group, you're going to list first the physical properties that you can tell from looking at it. So remember, some physical properties like color, or if it's shiny or dull, you can tell by looking at it. But other physical properties like melting point, you would have to do some other sort of test. So we won't talk about things like melting point, but the physical properties you can observe, we will. And then after you've written down your observations, then you're going to try and determine whether or not you think it's a metal, non-metal, or metalloid. So you're going to assign a type of element to each group. All right, so let's get started. The first thing you're going to want you to write down are the colors that you notice. And you can write down all the different types of colors because as you can see in each group, there's more than one color. So take a moment to write your colors down. Okay, how about phases? What phases do you notice? So remember, phases are things like solid, liquid, and gas. Again, there may be more than one type. So write down the phases that you notice. Finally, is it shiny or dull? So for each group, you can identify whether you have things that are shiny or dull, or maybe you have a mixture of things that are shiny and dull. So for each group, you're going to write down what you notice. Okay, so now based on all the observations that you have captured, which group do you think contains the metals? Which group do you think contains the nonmetals based on your observations? And finally, which group do you think contains the metalloids? Okay, so you now have some idea of what you think each group is, but before we reveal the answer, what we're going to learn about are the properties of the elements. So in addition to learning about the properties that you can see, we're also going to learn about properties you cannot see. And so for this, you're going to do a reading, and you're going to grab a reading handout, and you're going to read through the handout. And then either while reading or after reading, you are also going to take out the table which has properties of elements, and that should be on the back of the handout, so you can rip those apart if it's helpful, and you're going to fill in the table for the properties of elements. So as you're going, if you're reading about metals and you read that metals are conductors, you're going to fill that in. Okay, so make sure you read the instructions at the table first and also follow those instructions. All right. So you're going to pause this video now and do your reading and fill out your table. Okay, so what you probably may have said for each group is that group 1 is the metalloids, group 2 are the nonmetals, and group 3 are the metals. Maybe you've said that, or maybe you said something different. But one thing I want us to note here is that it's easy to tell between the metals and nonmetals. Like it's very clear which, if we were just given group 2 and 3, oh, this is metal and that's nonmetal. But it's not so easy between the metalloids and the metals because, you know, some of the metalloids like this one and this one, they look pretty much like metals. You know, they're shiny and everything like that. And you can't tell if it's malleable or brittle or not just from looking at it. So, so that's just to say that for metals and metalloids, you need to rely on other tests like the fact that metalloids are semiconductors and metals are good conductors in order to determine which one is which. Okay, now you can try this CFU. A shiny unknown solid falls on the floor and breaks. This solid is most likely a blank. Explain. So there's an optional sentence frame at the bottom which you can use to help you answer this question. When we come back together, the answers will be revealed. Great, so let's break this down from the clues. It says it's a shiny solid, so that could be a metal or a metalloid. We know that metals and metalloids are both shiny, and that most metals, with the exception of mercury, are solid, and metalloids are all solid. But then it says it breaks, so if it breaks, that means that it's brittle, not malleable, and that cannot be a metal. So we can say that this solid is most likely a metalloid because it's a shiny solid, which means it could be a metal or metalloid. However, because it is brittle, it must be a metalloid as metals are malleable. Okay, so now how can you tell if you have a metal, non-metal, or metalloid? In the previous example, all of the elements contain atoms that are non-metals. But how can we tell from just looking at that? Especially if we weren't given also the samples, like for nitrogen and chlorine, we can see from the samples, hey, these definitely cannot be metals or metalloids, right? Because they're not solid. So, so we could tell if we had that, but if we just had the chemical formula or the models, like how could we tell? And for that, we're going to use the periodic table. And you've explored this already in your previous homework assignment. And you know that the periodic table is sort of divided by metals, metalloids, and nonmetals. And you can somewhat color code it that way. So what you're going to do is you're going to pause the video now and grab a periodic table handout. And you're going to color code your periodic table handout using the color pencils and also fill in the blanks at the bottom to somewhat test your understanding about how the periodic table is arranged. Then when we come back, we're going to try several CFUs. Okay, so now that you've finished your periodic table handout, you're going to try this first CFU, which is talking about sulfur. So take a moment to read the CFU, and then we're going to come back together for the answer. So here is sulfur on the periodic table, if that's helpful. So in this question, you're told sulfur is a solid that is found in many natural compounds, which is responsible for the smell of eggs and flatulence. Which of the following elements is likely sulfur? And explain. All right, so now that you know where sulfur is in the periodic table, you're going to try it, try the CFU, and we'll come back together for the answer. Great, the answer is C here, and that's because sulfur is a nonmetal, so it should be a dull solid. Both B and D are shiny solids, and A is a gas, so it wouldn't fit here because we're told that it's a solid. Next CFU. So silicon is an element used in the computer microchips. Which of the following is likely true about silicon? Select all that apply and explain. So you can select one or more of these. And here is silicon in the periodic table if that's helpful. Pause the video now. When you press play again, the answer will be revealed. Great, so the answer here is B and D, and that's because silicon's a metalloid, and all metalloids are semiconductors and are solids. Last one, tungsten is an element that was used in light bulbs. If you hit tungsten, it would likely, which of the following choices would be true, and make sure you explain. So let's find tungsten here. The symbol is W, and that's where it is in the periodic table. Okay, so pause the video now. When you press play again, the answer will be revealed. Great, the answer is A. Tungsten is a metal, so it's malleable, so if you hit it or drop it, it will likely get dented or bent. All right, now that we have gone through utilizing the periodic table to sort of help us figure out